Please, all sounds should be on mute, please. All sounds on mute, please. Please, all sounds on mute, please. All sounds on mute.
I've been waiting to see these guys fight, and it does not miss a point. Yes, yes.
Hello, welcome to the masterclass. If you can hear me, let me see you wave. Can you hear me? If you can hear me, let me see you wave. Oh, okay. So greetings to all. Welcome to the masterclass session on creating a digital elevation model. And I'm your host today. I'm Mr. Cosmos from Geospatial Analysis, Mapping and Environmental Research Solutions. So I'm going to be taking you today through the steps of creating digital elevation model for your research, basically using the Google Earth software, the TCX software, and the ArcGIS or Quantum GIS or any other GIS software. Before this class, I already got a lot of complaints from people who are already telling me that the TCX is not working for them. So I'm going to show you a different way to use the TCX software and also capture your elevation. Are you with me? If you are with me, just nod so I will know you are with me. Everybody is on mute, so I can't hear you. Okay.
Yes,
okay.
yes. Yes, okay.
Okay, I'm going to be sharing my screen shortly. We have a lot of people in the waiting room already, so I'm going to be sharing my screen shortly so that we can proceed to the thing. So proceeding to sharing my screen, I'm going to be showing you what we'll be going through today. And this is it. So these are the steps we'll be going through today. So if you are with me, you'll be seeing my screen right now. And if you're seeing my screen, can I hear you nod? Can I see you nod if you're seeing my screen?
Yeah, okay. Fine.
If you're seeing my screen, can I see you nod, please?
Yeah, yes, yes.
Oh, okay. So we'll be going through the steps, and the steps involved is here. So we'll be doing it practical, but I want to take you through the steps involved in doing this, carrying this command, okay? First, you make use of Google Earth application, and we create a path using our path tool, and we are going to save the path on a location. Also, we're going to save the path in our place so that we can be able to move it to our file. So we are going to use this link. So you are going to take note of this link. If you have your pen and your biro and your paper, so I would advise you take down the link because the link is what we'll be using for this class. Okay, so the link is GPS visualizer .com/elevation. So let me zoom my screen so that you can be able to see it clearly. You can be able to see it clearly. So we'll be using this link. Then we'll be browsing those we saved a part as the KMZ, and we are going to be using this to just add elevation to those points. And after adding elevation to those points, we are going to use it, the points as CSV to run whatever we are doing concerning our digital elevation model now. You can also verify the accuracy when you are done. So first step we are going to do, we are going to open up our Google Earth application. So I want to unmute I want to unmute you so that I can be able to hear you when I'm communicating with you. But please, I would appreciate. Don't worry, you get the slide and everything. So if you are just be on the chat room, if you are hearing me, if I ask whether you are hearing me, just reply me with yes so that I will know, because I can't see most of you because your video are on mute. So this is my Google Earth interface. So looking at my Google Earth interface, you can see I have everything is in place. So depending on what you are doing. Now I can show you several ways you can be able to do this thing. One is you can possibly be able to do it by searching for the location. If I'm working on Lagos, I can type Lagos here on my Google Earth and search Lagos, Nigeria, and search for it, and then the system is going to take me to Lagos. So if I'm working on Lagos, the system will automatically take me to Lagos. So if I'm not working on Lagos, there's another format which I normally use to be able to access my study location. Okay. Normally, if you want to access your study location using GIS, you find out that probably you are working in a place like probably I'm working on. Let me use a city or I'm working in a city like Ogun. Ogun is a local government in Nigeria. So I'll open it up so that you can see it. So if I'm working on Ogun now and I already have my local government boundary. I already have my local government boundary. Let me show you my local government boundary so you can see it. So you see, you can follow along what we are about doing shortly. So my local government boundary, this is my local government boundary. Zoom. Okay, this is my local government boundary. So if I'm working on this local government boundary and I require, okay, I'll be loud. If you're working on this local government boundary and I require to do an elevation map of this local government boundary. So the first thing I'm going to do is you can make use of your ArcGIS to save this particular shape file as a KML format, which is a format which is supported by Google Earth. So if you don't want to do it that way, there's another way to do it. I have a software called GPS Track Maker, so which is what I'm going to be using. So if I select my GPS Track Maker now, can you hear me? If you can hear me, say hi. Let me know you are hearing me. If you can hear me, say hi.
Yeah, here.
Okay. So looking at this local government boundary now, which is the area I want to put up the DEM. So what I'm going to do is now I'm going to go to file here, use this software to open up the boundary. So if I use this I'm going to open up the boundary. So open up the boundary now. I'm going to locate this particular file in my GIS environment, in my working folder. So I have LGA. I called it LGA. So I'm going to open up the shapefile. This is the shapefile, and I'm going to open it up here. This is different from this class, but you can also grab it. So I'm going to make use of this for my work. So if I right click on the boundary, I can select the boundary, any boundary of my choice, and press OK. So I already have a boundary here. So what I'm going to do next now, I'm going to save it as a Google Earth format. So my file environment is Ogu. So I'm going to go to the file and save it as KML, which is Google Earth file format. Oh, you're free to open your Google Earth if you have it. So see, this is my LGA boundary. So I'm going to save it as the format of KML. So if I go to my Google Earth right now and I wish to locate this particular place, oh, sorry. So this is my Google Earth environment, and I make use of software called GPS Track Maker. I'll take you back there. So GPS Track Maker is a software which I can be able to use to this is the software. I can be able to use it to get my boundary. So I've already saved my boundary as KML. So I'm going to look for my local government boundary. I call it LGA boundary, and I'm going to open it up, the LGA boundary, and this is the boundary. So when I right click at the edge, I'll set the line, set it to line so that I can be able to see through whatever is inside. So now I can see whatever is inside. So I'm going to save it now as KML. KML is a format which is being supported by Google Earth. You see Google Earth file, which is KML. So I've already had it before, so I'm going to save it. Okay. So now I've saved it. So now I've saved the file. So I'm going to go to my Google Earth now. So let me share my Google Earth screen. So this is my Google Earth interface. So you can see my Google Earth. This is the environment. So I'm going to browse out this file, which I want to use to configure the DEM. So I already have it here. So if I click on it, it's going to take me to the environment. So this is the environment of my study, which I wish to map or create a digital elevation model of. Okay. So I'm going to zoom in. So this is my environment, and you are going to get this section on the video record. So if you're not getting me, just exercise patient, watch through what we are doing. When we are done, you are going to get the full video. So now looking at this interface now, I have interface and I have my boundary, which is my working boundary. So the next thing I'm going to do, I'm going to pick these two. There is this two on top of the Google Earth, is like a line with points. It is called part 2. After the point, the polygon, that's the next two, is a line 2. So I'm going to pick that 2. So you see it, new part 2. So what I'm going to do now, I'm going to click and hold down my mouse while I try to cover the area. So this is the one I'm holding it. So I'm using this mouse to draw around my points. I'm trying to draw around my points and as much as possible to cover the whole area which I'm trying to get the DEM. So those red dots you are seeing, those red boxes you are seeing are the points which the system is going to use to generate the elevation. So you try to cover as much as possible, as much area as possible, so that you can be able to cover your study area. So that is what I'm trying to do. So I'm trying to cover my study area with these lines and marker. So that is what I'm doing. So covering this marker with my environment. So this is what I'm doing. So you try to make it as dense as possible, because you know the more the points, the better the accuracy. Understand? So if you do a 5-point DEM, the accuracy is going to be low. But if you are covering the area very well, and if you make it dense, it means that the area, the accuracy will be better. Okay. Also as the cell size will be also better. So I'm trying to cover as much area as possible so that I can be able to use it. So, but for the purpose of this class, I'm not going to make it very dense. But on your own, you can make it as much dense as possible. Okay, you can make it as much dense as possible. So now I'm making the marks around it. So I'm done with the marks. So here I'm going to come to this Google Earth new part. So what I'm going to do here now, I'm going to save this part which I have created.
Yeah,
so
no, you know. You want to study the one now?
Please, all on mute. Please, all on mute. So can you hear me? If you can hear me, let me hear you say hi on the comment section. Please make hi on the chat section if you can hear me.
Hi.
Oh, okay. So now I've created this part, and you can see the Google Earth catalog, the dialog box for Google Earth new part, which is beside you at your right side, at your left side. So you're seeing the title, untitled part. So what I'm going to do now, I'm going to change the name to the location which I'm studying, so that I can be able to locate it when I get to my file. So I'm going to call it Ogo, which is the area Ogo DEM point. So to make it very easier for me to locate this file. So when I've saved it as I've created Ogo DEM point, so I'm going to click on OK so that I can save the file. So once I click on OK, you find out that this file will now come to my place. If you look at the place, there's by your right, there's a place which is written as place. Okay. So if you look at this place is directly under the search box on your Google Earth. So you can see my Ogo DEM point, which is down. This is a line with points, which is what I'm going to be using to get my elevation data. Okay. So now I've saved it here. I'm going to do the next step, which is to save this thing to save as a KMZ file so that I can be able to use it. So I'm going to say, right click here on the DEM point and say save place as. You see the save place as. So I've selected the save place as. So I'm going to browse my location and save it as DEM point KMZ. So the KMZ file is what we'll be using for this illustration. So we save it as KMZ. Okay, so now I've saved a KMZ is in my file. The next thing I'm going to do now, I'm going to go to my web browser. So I'm making use of my Google Chrome. So I'm going to go to my web browser to I'm going to go to my web browser. Okay, so let me open my web browser. Okay, this is my web browser. So I'm sharing my web browser. So you can see my web browser on your screen. So if you can see my web browser right now, just write hi so that I will know you are seeing my web browser. Okay, so we proceed to the next step. So I'm going to go to the title to this address. So remember I told you one thing. I told you there's an address which is in this file, which is I'm going to show you again, which is www.gpsvisualizer.com/elevation. This is the link which we are going to be using to add points to our file instead of using the TCX, which is no longer functional as before. So I'm going to go back to my sharing screen and go back to my Chrome. So this is my Chrome file. So I'm going to paste this address on my browser. So you see, I'm going to paste this address on my browser and hit enter. So I'm going to paste all this on web browser, okay? And I'm going to hit enter. So this is the interface of the website which we are going to use to generate those elevation points into our already created KMZ file. That file is called KMZ file because it's an XYZ file which already contains the XY, which is the coordinates, seeking to get the elevation. So what this website is going to do is going to generate elevation into our point. Instead of using our TCX file. So what I'm going to do now, I'm going to go to this upload and choose upload. So if I choose this upload, I'm going to locate the place I saved my KMZ file, which is the file I'm working with. So I'm going to locate Orgu, which is my working folder, and I'm going to look for the Orgu KMZ. I'm going to look for my KMZ file. Okay, let's look at it. You can see it on my screen here. Orgu DEM point KMZ. So this is my file, which I'm going to be using. So what I'm going to do, I'm going to click open. So the system will load this file on my screen. So if you look closely to this dialog box, you will see that my file is already there. You can see from that choose file, you see Orgu DEM point.kmz. We already added my file, which is our KMZ file, which we are going to be using. So the next thing we are going to do is for us to add elevation to it and export it in a format that can be used on TCX. So what are we going to do? We are going to click on this button which says convert and add elevation. So we click on it. So it's going to convert it for us and add our elevation. So once it's done, we can now download it. So you see, we have converted and added our elevation. So if you're looking at your screen now, you can see a download link which is being shared to you. There's a download link here. If I move my mouse here, you will see download link. Click to download 2020073. So this is our download link. So if I click on the download link now, I'm going to download my file that contains the elevation. Okay, if I click on the file now, I'm going to download my file that contains the elevation, which is in GPX format. And this GPX format is recognized by TCX. So you see where the TCX software comes in. Because it is recognized by TCX, so we are going to download this file and now use the TCX converter to convert what we have here to CSV. So the CSV is what we are using to plot our elevation. Are you with me? Are you with me?
Yes.
Yeah,
yes.
yeah, yeah.
Okay, so the CSV is what you are going to use to plot your elevation. So we are going to download this file. So we are going to download this file right away. So we have downloaded the file. the file as is 20020073. So I've downloaded the file. So the next thing we are going to do is for us to go to open our TCX file. So I'm going to share the screen. So this is our TCX converter. So I'm very sure that every one of us downloaded the TCX converter. Okay, can we focus, please? So I'm very sure that everybody downloaded the TCX converter. So what I'm going to do, I'm going to click on this open file.
Yeah.
I'm going to be clicking on this open file.
Yes, I have.
I'm going to click on this open file, and I'm going to browse where I just saved the file which I downloaded, which contains the elevation. So it's in my download. So I'm going to locate my download, and I'm going to see the file here. You can see the file here is say 20200-73109. That is our file. So I'm going to click open. So as I click open now, it is going to load all the points with the elevation. So you see the TCX is functioning now. It's loading your points. It's loading your points. So you can see we have the time subtract 0, the latitude, the longitude, the altitude is now in the point. So we now have the altitude.
That's very interesting.
Yeah. So what you are going to do now is you are going to go to the upper right side of the TCX. You will see save CSV file. You can see it at the one of those buttons there, the top, the second one on the right. You say save CSV file. So I'm going to click on save CSV file.
CSV file means comma delimited file.
Exactly. That is the comma delimited file, which is the one that is used by Quantum GIS and your ArcGIS. So we are going to save it now. It's no longer normal like any other file. It now contains the elevation, which is what we are looking for, which is what TCX does not offer us now because it's no longer functional. So we already have the file. So I'm going to now browse my working environment to save this file. So I work with my local hard drive. So I'm going to go to my local hard drive, open it, go to my GIS folder and click on GIS folder. Okay, so I'm going to locate Ogo. So this is my Ogo. So I've located the area. So the next thing I'm going to now do is I'm going to now save this file. I'll edit it and call it let me edit the file and call it DEM. I call it DEM point file. Sorry, DEM point file. So I normally give it a name that will make it very much easier for me to remember. Okay. So I save it as DEM point file and I click on save. So it will now ask me, focus on your screen now. This is where a lot of people get it wrong. So now you say, press yes to use comma as separator and press no to use
excuse me, sir,
as cell separator. Okay. So if you use comma as cell separator, it means that you are going to get it cell by cell. Okay. Are you following? It's going to get it give it to you cell by cell. But if you click yes, it's going to lump all the data together and use comma to differentiate them. So we are going to select no because we are going to select.
This concept is not clear.
I can't hear you. You say
this concept is not clear.
Okay, I'm going to I'm taking it back. I'll take it back.
Kindly say again.
Okay, I'll take it back. I'll take it back. Don't worry.
Thank you.
Okay. So what I'm going to do now, I'm going to click as save as CSV, and it's going to open up. So I'm going to select the file which I want to use to save the file and the file name, and now click save. Are you with me? I'll select the file name and click save. So it's not going to give you this particular dialog. So what does this dialog ask of you? It's asking press yes to use comma as cell separator and press no to use the normal comma as cell separator. You see the first one is inverted comma. It's not inverted, it's a semicolon, while the second one is comma. So what we are looking for to use is the comma, not the semicolon. If you use the semicolon, you cannot be able to analyze your file easily. You have to manually separate them. But if you use the comma, you are going to, it is going to arrange them cell by cell, which is what you are looking for. So we are going to select no. We select no, and it exports the file. So,
it's okay.
We selected no. We selected no. So we are going to now go to the next step. The next step is for us to open our GIS software. So I'm going to illustrate with ArcGIS, and I'm going to also illustrate with QGIS, so that those who don't have ArcGIS can be able to still benefit in the knowledge, because ArcGIS is a licensed software, while QGIS is an open source software. Are we following? Are you with me?
Yeah, Will.
Okay, so next step I'm going to take is I'm going to go to the ArcGIS. I'm going to select file. I'm going to select file, and I'll go to add data, and I'll select add XY data. Are you seeing it now?
So a point, Will.
Ask XY data. So I'm going to
Then
browse and locate the
we
points.
can add XY data from comma delimited file.
Yes, we are going to get the from the CSV. Yeah. So look at these files now. I've already gone to the file location. So you see our file, the DEM point file.txt. So we are going to add.
Yes.
We have added now. Okay. And look at now, the system of automatically assigned the X as longitude and the Y as latitude. Okay. So we are going to press OK, and it's going to ask you this table you specify does not have an object ID. We say OK, because tables do not contain object ID. But when we move it to a shapefile, it will contain the object ID. So we are going to save now and now export to shapefile, so that the object ID will be added to the file. Okay. So we press OK. We press OK, and the file will be added to the system. So you can now see the points scattered all over my screen. Can you see it?
Yeah.
Yeah. So
clear. This concept is totally clear. Very good. Thank you very much.
Okay. So the next thing we are going to do is, this is my point, which is the DEM point file, but now it's still in table format. So I need to convert it to shapefile. So I'm going to right click on that point here, go down to my data. Go down to my data. Are you seeing it? Then go to my export data. So if I select my export data, I'm going to save now as shapefile inside my working environment. So I'm going to call it again, DEM point file. But this time around, it's now saving as shapefile instead of as a table or CSV. So it's not a shapefile. So I'm going to save the shapefile, and when it's done exporting, we have 2050 shapefile points, which we are going to use to interpolate. So we have 2050 points which we are going to use to interpolate. So now the system is going to ask you this question now. It's now processing. So do you want to add the exported data to your map layer? We say yes, because we are using it in the map layer. So it's going to add it. Now look here, you will see it. It's now in green, so we don't need the table. We remove the table. We are focusing on the point, which is our shapefile. So now we have gotten to this level. The next thing we are going to do is for us to run the interpolation. So the interpolation is for us to be able to now interpolate and come up with the digital elevation model. Okay. So it's going to enable us to come up with the digital elevation model. So the next thing we are going to do is for us to go to the Arc toolbox. Arc toolbox is a toolbox in ArcGIS which contains a lot of function. It contains the function which we are mostly using. So
excuse me, when we add the data in ArcGIS, then I should prefer Arc toolbox.
Yes, we go to Arc toolbox. So Arc toolbox is where we normally have our tool. So if I go to Arc toolbox, I'm going to go to Spatial Analyst 2. So if I go to Spatial Analyst 2 on the Arc toolbox, okay.
3D analyst.
If I go
3D
to
analyst.
Spatial Analyst 2, so I go to interpolation. You see interpolation now is now open. You can see my interpolation. Interpolation. Special analyst
tool.
2.
Then
go
okay.
interpolation.
Okay.
So I prefer using the IDW. You can use any other method which is suitable for you, but I normally use the IDW, which stands for inverse distance weighing. So the IDW stands for inverse distance weighing. So we normally use the IDW. I normally use the IDW. You can use the Kriging.
Inward distance
weighing.
Weighing?
Weigh. To weigh something, to weighing. Inverse distance weighing.
Spelling?
W-E-I-G-H.
Okay.
Yeah, weighing. To weigh something, to check the weight or the size. Weighing.
Okay.
Yeah.
Okay.
So I'm going to use the IDW. So I double click on the IDW points. So it's going to open. Okay, it's going to open.
Okay.
So now the IDW is open. Uh, so so now the IDW is open. So the next thing I'm going to do for you is I'm going to select a point, the DEM point file, which is in a shape file. So if I select it, I'll add it at the input point feature. So if I add it at the input point feature, okay, it's still loading. I'm going to adding it at the input point feature. So it's now added at the input point feature. So I'm going to select the Z value, which is the altitude. You see the altitude as part of the attribute, which is the Z value. So select the altitude. Now, if you like, you can decide to browse the location of your digital elevation model. You can decide to save, depending on what you are doing. So I can decide to browse the location and save it wherever I want. So I will call it DEM from points .tif. I like using TIF so that it will not scatter my files around my system. So I will save the file, or you can decide to leave it like that, depending on what you are doing. So I'm going to, after I've arranged the input the point, which is the DEM point, added the Z, which is the altitude. And now,
Kindly repeat the step.
you will get it on the video. We don't have time right now, so that
Oh.
everybody will be carried along. Okay, I'll send you the full
Oh.
video, so you get the full video. So what I did now, I added the input point, then I selected the Z from the attribute, which is the altitude. Then I now set the output, which is where I want to save this particular raster, which I'm creating, which is the DEM. I selected the output location and the file name. And now I'm going to select my OK. So with OK now, the system is going to run interpolation for me, and it's going to add it automatically in my, okay, so you see, I already have my DEM on my system. So if I remove the point, this is my digital elevation model here. So I can decide to style it to my taste. I can decide to style it to my taste if you know how to use the symbology tool, which if you don't, we are going to be treating that one later on, not here. So I'm going to create 10 classes. You can edit to your, as your according to your choice. So you can edit the interval, you can make it 10, you can make it equal interval, depending on what you want. So you can choose the color scale and other things. So these are class for different classes. So I'm going to select OK. You can also decide to make it a 2 decimal place file or 3 decimal place file so that it will reduce them, and I press OK. So this is the file I have. This is my digital elevation model. So you can see my digital elevation. So you can see the you see it on the legend, the values 63.3 to 104, 105 to 145. So these are my values. So you can decide to color based on your choice. So it doesn't, based on your choice, you can decide to color. But I normally like using this color for this elevation model because it's like more like the earth color. So this is the earth color. So now that I've created this now, I can now choose whether I want to leave it like this, I want to crop, or I want to crop the area. So I can try to crop the area and make them assume my boundary size or shape and whatever using the masking tool. So we get to know about that one in the next class, which is coming up. So if you stick around, we are going to join the next class. I will take you around how to mask out these features and make them finer and assume the shape of your shape file or the shape of your study area. So we don't have time on our side. So let's migrate to Quantum GIS and see what we can do using Quantum GIS. So we don't have time on our side. Let's migrate to Quantum GIS. So because our timeout is already reading. So we are going to proceed to Quantum so that we can see how to do it also in Quantum. So meanwhile, let me take you through how to mask this out. So if I want to mask this out and make it assume the shape of my boundary, I am going to go to the Add Toolbox again, and I'm going to go to the extraction tool, and I'm going to go to Extract by Mask. So you see Extract by Mask. I will select the DEM, which I newly created, the file and DEM from point. Then I'm going to select also I'm going to select also the input raster or the vector which I wish the system to mask my DEM according to. So I'm going to use my local government boundary as my mask so that the DEM will assume the shape of my local government boundary. So now that I've done that, I'm going to press OK, and the system is running. Okay, completed. So this is the digital elevation model. Now is now assuming the shape of my working environment. So I can decide to do whatever I like with it. Go to properties, use classified, make it 10 classes, choose equal interval, set the file, set the decimal places to 2 if I or 3 if I wish to, and other things. Change the color to the preference color of my choice. And normally I like doing the display, setting it to by linear interpolation for smooth rendering. So once I go to display, I select the bilinear interpolation, it gives a smooth rendering of the topography. So if I press OK now, it's going to classify my topography. So you see what I have here. Okay. So you can decide to add other tricks, which is going to symbology and adding a hue shade format effect. So if I add a hue shade effect, you see the effect. You can see the effect of hue shade on the digital elevation model. I can decide to make it 0.05. Apply. Let's see. You see the effect. It gives it more like something that looks more like a 3D texture. Okay, it gives you something like looks more like a 3D texture, and it's really nice. So if I change the color, you will feel the impact very well. So if I change the color now, you will feel the smoothness. So you can see the smoothness and the rendering of this particular point. So probably let me make it 1.7 to make it smoother. And you see what I have. So if I use the hue shade effect, it's going to look really nice, like a 3D digital elevation model. So you're going to get this video. We are going to run through this thing in the next class. So don't rush. We'll run through it in the next class. So let's look at how to do the same thing with our Quantum GIS also, so that people who make use of Quantum GIS will also benefit from this class. Okay. So these are elevations. So from this elevation, you can decide to calculate your slope. Okay.
Hello.
Yeah. The exercise questions. I'm loading my Quantum file. So ask your question while our file is loading. I'm trying to load the QGIS software. So ask questions.
Can we determine the resolution of this image? How much resolution it is?
Okay, if you want to see the resolution, you go to your properties from the DEM, and you go to your source. So from the source, you can see the resolution. The cell size are 0.000918869 by 0.000918864. It's the same, is at the micro level. Because I selected close points, the details here is much better than using your digital elevation. Because you know most of the digital elevation are at 20-meter interval, but here the interval is not as much as 20 meter. Okay.
And how to check the accuracy level of this digital elevation model?
Okay, if you have an existing DEM, you can use it to check the accuracy level, or you can also pick some points on your elevation, just like the normal way of assessing your accuracy level used in your Landsat imagery. So you can pick already existing elevation on your field. Like if you are studying a place and you have gone to the field, you have collected some elevation, okay, you can decide to use it to match what you have on the map and see what the accuracy level is like, whether there is a significant difference between what you have on the map and then what you have on the field. So if you run a statistical analysis on it, something like a student t-test or a chi-square, you can be able to tell whether there's a significant difference between what you have on the field and what you have gotten with the DEM. Okay?
Okay, thank you.
So our QGIS is open now. So let's
sorry, can it be QGIS also?
Okay, let's rush over to QGIS so that we can proceed to the next. Okay, so this is our QGIS interface. I wish everybody is seeing it. Hope we all are seeing the QGIS interface.
Yes, sir.
Okay, so what we are going to do now in QGIS is that we are going to add the CSV. We start with adding the CSV format file to here. So we are going to go to layer, you go to add layer, you select the you see it down here, you select the I'm sorry, create